Hi and welcome to this video in the MRDCL series, and in this fundamental series one of the things I want to get over in this video is just to give you a background to what MRDCL is doing in terms of processing, so you understand perhaps a little bit more about what's going on in the background, and also give you some names to files that will get referred to in subsequent videos. So what we're going to look at here is what I'm going to call steps and stages. We've already in the earlier videos looked at some of the stages that you have. We've got a control stage, we've looked at a data stage, and we've looked at a table stage. There are two more stages in MRDCL. These are a manip stage and a print stage. Just to get the print stage out of the way first of all, that's one that's very rarely used, but it's a stage where you can specify what tables are printed in a given run. So you might just print out tables 1 to 9 and 20 to 25, but not print the others. And that particularly can be useful perhaps where you've got a syndicated project where you may have 100 tables and client 1 gets tables 1 to 10 and 11 to 20, client 2 gets 1 to 10 but 21 to 30, and so on. So you could actually have separate print stages that give different volumes of tables for different people or different clients. The manip stage, which is the other stage I've mentioned, we haven't encountered that so far, but that really is a stage where we'll be covering that in later videos, where you can manipulate incremented tables. So let's say you wanted to have the third row of your table to be the sum of two other rows, or the first two rows. You could specify something in the manip stage which would add rows 1 and 2 together and give you the result in row 3. So this is not working with respondent data, this is reworking with incremented data, or incremented tables. So the stages here we're going to go look at today, we are going to stick in this session to data stages and table stages predominantly, but it's worth just going through what happens when we run an MRDCL script and understanding that just a little bit more. So if we run an MRDCL script, we get the options to compile, execute and print. I'll come to what the compile, execute and print and export mean in a moment. And it runs at the screen here, and if you've looked at this you'll see it's gone through a compile phase at the data stage, then it's executing the data stage, then and tells you how many records it's written and how many records it's got in the IDF, and then it does the tables, increments the tables, and finally produces you some tables, and it tells me here I've got 101 pages. So let's look at that in a little bit more depth just to understand what's going on. So first of all, what happens in the data stage? Well, in our data file, data1.asc, we have 3 records. So if we just look at what's going on here, what it's doing is it's effectively putting each of those 3 records through all this code here in the data stage. So this is all of my data stage, not a bit too far. There it is finishing down there. So everything between start data and finish data, it's processing. And what it's doing actually is processing 1 record at a time. So 1 record comes in here, it goes through, it deals with question 1, it deals with question 2, it deals with all the variables until it hits the finished data, and then it writes that record to what we call the IDF, which stands for the intermediate data file. Now that's a very important file in MRDCL, and I'll be coming back to that in a little while. So we produce this IDF, and then having got that one, or that first record to the IDF, it's effectively going back to start data, reading the second record and doing all that work again for the second record, and then writing that to the IDF. So what MRDCL is doing, you can think of, is going through the data stage as many times as there are records in your data file. So if you had 1,000 records, it would be performing that task 1,000 times effectively and writing 1,000 records to your IDF. And if we look at the finished data statement, what that's doing effectively is writing your records away to the IDF for you. Then it comes to the table stage, and the table stage says, well, how many records are there on that IDF? And in this case, it's 3. And then it's going to process those 3 records and add them to all of our tables. So again, it's taking the 3 records in the IDF and getting them to fill in the tables one by one, you can think of it, and incrementing those tables so that we get a set of tables in what's called the ITF, or the intermediate tables file. If we had a manipulation stage, it would manip those tables. So it would take those incremented tables, and to use the example I just gave, if on table 1, for example, we were adding row 1 and 2 together to make row 3, it would perform that manip stage after incrementing the tables. And then finally, it's going to go through and perform a print stage or a print step and produce the tables where it doesn't actually print them but makes printable tables that can be in a text file or a CSV file. So that reflects what's going on when we run this at the screen and we get these messages. We're reading 3 records, we've reached the finished data 3 times, none were rejected, all 3 were accepted, and therefore there's 3 on the IDF. When we get to the table stage, there's 3 records to read. It does those 3 records because it's so few in one pass. If you have a bigger project, you might see that come up with saying that it's going to take 10 passes or 20 passes. It carries out those passes and it will actually number those 1, 2, 3 if there's more than one, produces our tables, and then it can actually format those tables ready for printing using any manip previously, if there's any manip stage, which there isn't in this example project. And so what the print step is doing effectively, or the print phase, is it's pulling together all the figures, putting them into nice looking tables, using any format options you've requested, such as percentaging, stats, and all the other things that can control a set of tables, and finally giving you an output, in this case, with 101 pages in it that are ready to print or view using an editor. So that's what it's doing. So let's go back a step now, and we saw here that we had 3 lines read and 3 records, and it put all 3 records to the IDF. Now there are ways of stopping that, and there's ways of actually controlling that. In this particular case, because there's a finished data, the finished data is effectively writing that record to the IDF. If we put a write command in there, the write command replaces the finished data statement in the sense that it's writing the records to the IDF. The finished data is just a marker to say it's the end of the file in that case. And in that case, it would make absolutely no difference. Don't ever do this, but just to illustrate this point, if I put 2 write commands in, and I can't think of any way I would want to do that unless you really wanted to cheat and double your sample, and I ran now, look what we get. We've got 3 records read, but we'd have 6 records on the IDF because it's writing those records twice for each record. Now, of course, that would be totally cheating and we'd never do that, but that's what it would be doing. But we can filter that write command. We could say if Q1 answer 1 write. So the only people that get written to the IDF are the ones that fulfill that condition. And if we run that now, we do only get 2 records on the IDF because one of the records didn't have answer 1 at question 1, which means now our tables are processed on 2 records, not all 3 records. It's going to exclude the one that didn't fulfill that function or that condition at the write command of Q1 answer 1. And there are other tools in MRDCL to exclude records. As we'll see in subsequent videos, you can exclude records based on various criteria. So, for example, if somebody was a screener only in your survey and they didn't complete criteria to take part in the survey, you could specify what that was, and you could say, I want to exclude them, rather than perhaps filtering the write statement as I did here. So that's controlling the IDF. Now, the IDF is an important file. When you make an IDF, as I've done just again now with all 3 records, if you were ever to export from MRDCL, what you would export would be what's on the IDF. So if I chose to export this now to SPSS, it would export just the record sitting on the IDF. That was previously 2, I've now set it back to 3, so it would actually export all 3 records. There's a video covering exporting data in much more detail that's in the series as well. But just to talk about the principles then of what happens with an IDF and what it's doing and what it's storing and what would happen if you export from it. So what is on the IDF is really what MRDCL thinks as the core data that you're going to run from there on. So let's look at that. Let's now go back to the Go window and look at that. So the steps that we have here are compile, execute, print, export with some other options down the bottom. So if we just compile, it's not going to do anything else except check that what we've done makes logical sense and is okay to compile. And here I've done that, I've compiled it, that's produced no tables, it's done nothing except compile it. It's just made it into, performed a run that just checks that what I've got is syntactically correct and logically consistent. Let's do it again. If I compile and execute, it's going to compile everything I've done and it'll produce an IDF, but it's made no tables. Now, one of the things you can do, you can also obviously go on and compile, execute, print as we were just now. But one of the things you can do, and this is not really helpful on a small project like this, but if you wanted to change a piece of text to XXX, you could just compile and print. You wouldn't need to execute. You only need to execute if you're rereading the data, changing how you write the data or what records you're excluding, or you've changed the tables. All I've changed here is a piece of text. All I'd need to do is compile, and if we look at question 1 now, we should find that that piece of text, without executing, has changed yes to XXXXXX. I'm going to set that back correctly so that I don't forget. Alright, so that's how you can compile. The same applies to format options there. If you made an error with any spelling errors, of course that covers, but if you made a correction was needed to a format option, you could also rerun with compiling and printing without re-executing. However, if I picked up the wrong codes here, I would need to execute, because say I picked up 1 and 2 here and I should have picked up 2 and 3, I would need to re-execute because MRDCL would need to reread the data, remake the IDF with that new definition, and it wouldn't be appropriate just to compile that. Now, the other thing that you can do, and this is something that many users don't take advantage of, but I think is a real advantage on big projects, is to split their setups. You can, if you wish to, split this setup into 2 parts. Now, of course, this is a very small project, so it ran the whole thing in just a matter of a few seconds. But let's say we had 100,000 records here and we were producing 5,000 tables. I would call that quite a big project, and it would take probably some minutes to run. What we can do is we can split the setup. So what we can do here is we can take what's in the data stage. So let's just do that. Let's go from here, line 1. I'm going to call it get started 6a.stp and take the rest of the setup here, the tables, and put them into a separate script here. .stp, and now I've got what's called a split setup. So I've got a table stage in one file and a data stage in another. Now every run must have a control stage, so I will need to add a control stage in here, otherwise it won't know what to do. I also need to tell it that the IDF for this project is get started 6a. I don't need the STP on the end of that. So now I've got a split setup with my data stage, if you like, in get started 6a.stp and my tables in get started 6b. So I just need to copy these over from Q6a because 6b is also referring to those, and I can just paste those in the top somewhere and save that. And now when I run that, I'm getting my tables in here, and they're just coming off the IDF from Get Started 6a. Now, why is that useful? It means that if I've got a big data file I've got to read, that stage running Q6a can be carried out, and once it's right, we can effectively freeze that, and then we can pull tables off, which might be much quicker, separately in 6b. And if we wanted to add tables or change tables or correct tables or delete some tables, we wouldn't need to run the big part of the process reading all the data up in 6a. So we've successfully got a split setup. As I say, on a small project that's not a great advantage, but on a big project that really can save you hours sometimes of processing time, particularly if you've got lots of runs. I know some clients I have who run some tracking studies where they produce many volumes of tables, and that's a really efficient way of building their database, storing it in an IDF, and then running multiple sets of tables. So that completes this video, just giving you an introduction to what stages and steps are all about. You'll find out more of this as you learn more from the other videos on more specific topics. Thank you.